you for flying halfway around the world to be with us. And thank you all for being kaitiaki of free-flowing knowledge. Nau mai, haere mai, ki APAN62, kia ora. I would now like to introduce Helen Robinson, the RIANZ Board Chair, to say a few words.
Thanks, Amber. How fabulous was the Pōwhiri? It was amazing, right? Yeah. And it kind of reminded me that just a couple of weeks ago here in Aotearoa, New Zealand, we celebrated Matariki. And Matariki is about the past, present and future. And I encourage you, maybe a little homework for you all, go away and look up Matariki. And it's quite poignant, incredible, and says a lot about us as people and about New Zealand and what we care about. As Chair of RIANZ, I am absolutely delighted and feel very privileged to welcome you and officially to APAN62. This week, we're joined by delegates from over 30 countries and economies, more than 170 organisations, universities, national research and education networks, research institutes, government agencies, technology partners, and international organisations from across the Asia-Pacific region and beyond. And what Amber talked about, really this better together approach is so important, isn't it, as we work together to define what the future of our world looks like. And often, what RIANZ and what we do is almost unspoken or not recognised, but we recognise it, and we recognise the importance of what we do. It really says so much about this community in which we are involved. It's easy in our busy lives, busy organisations, fast-moving fields, to become focused just on what's directly in front of us. But what APAN does is it reminds us of the value of stepping back, of coming together, seeing what is possible, and looking beyond the borders of knowledge and how we share all the learnings, knowledge, experiences, the future. What do we want this world to be as we move forward? The challenges that APAN helps address are actually more ambitious today and will continue to be. I entered the tech industry in the mid-80s and watched this absolute fast-paced world, and it's only continuing. And I think that's absolutely exciting. But whether it's understanding our changing climate, improving health outcomes, advancing AI, strengthening cybersecurity, or supporting the next generation of researchers, none of this work can be done by a single institution alone. Better together. It depends on capability that extends regionally and indeed globally, as is illustrated by the room of amazing, diverse peoples. Secure movement of data, access to advanced computing, shared standards, skilled people, relationships built over time and time and time again. And much of the work sits behind the scenes, but it's the foundation that allows researchers, educators, and innovators to ask bigger questions, work with bigger data, and collaborate with confidence. And for us here at RIANZ, that's at the heart of our role. We're here to help ensure that New Zealand is not limited by the distance that Amber talked about, by scale or geography, but that our researchers, educators, innovators can connect into the systems, expertise, partnerships that they need to do world-class work. And as a nation, we're very proud of our innovative spirit of the outcomes that we achieve, and REANZ really is helping enable and support that. Hosting APAN62 is an absolute privilege. It brings the wider system of capability here to Aotearoa, the people who keep research moving, data flowing, services trusted, and ideas connected across the region and across the world. So on behalf of the REANZ board, thank you to APAN, to our sponsors, partners, and to everyone who has helped bring this week together, and to all of you who, how many have come for the first time to New Zealand? Many? Yeah, quite a few. So now you know what we have to do when we have to fly halfway across the world all the time. But we know that it's worth it. And we recognise the importance and the commitment that you've made in order to come here. I hope this week enriches you with valuable conversations, connections, practical insights, and that you leave here with new ideas, stronger relationships, and a clear sense of what this community can make possible together. Ngā mihi nui.
I'd now like to invite Shinji Shimojo, Chair of the APAN Board, to come and say a few words.
So thank you very much to having this nice venue and nice opportunity for all of us. So distinguished guests, ladies and gentlemen, on behalf of the APAN community and as the APAN chair, I would like to officially thanks to all the organizers, especially Amber and the distinguished guests, to make this wonderful opportunity possible. I'm very excited to get more energies through the official welcome in Maori way. Actually, this is the first time for me to experience that, So as you see, this is actually the how people meet to each other. First, I think worries, and we have a suspicion to other people. But after I go through the real welcome, I think we can make connections, and connections make trust through the conversation or through the collaborations. So I think APAN itself is a very good opportunity to make us have stronger trust and stronger collaborations and get the work. I got the energy from Maori people, and all of us get the energy. So let's get to work and let's get to collaborate. Thank you, and kia ora. Thank you very much.
Kia ora, Shinji. I have someone from Flex Optics, and I'm afraid I don't know who that is, coming to say a few words. Sorry? Rashi? Dashi. Dashi. No, can't miss you, yeah. I think you might need some help. Have you?
Yeah, I have a connect here. Let me see if we can do this. Kia ora, everyone. I'm Tashi. As you can see, I'm originally from the Himalayas, not our Maori cousins here. Our sizes differ, but I'm from Flex Optics. I wear this orange shirt. Our orange mothership is in Germany, but I'm the APAC technical lead for Flex Optics. I don't do this usually for Flex Optics, but Leanne insisted we introduce Flex Optics. We don't do these things well, Flex Optics, just because of our philosophy. So I thought maybe I'll start with how we disrupt things quite a bit out there in the industry, and we believe that life doesn't have to be difficult, or things don't have to be done the conventional way all the time. This is what we do. We have universal programmable transceivers. We give you a programming box like this and go have fun, program it for any vendor you have. That allows you to just focus on the optical engineering aspect. You don't have to go worry too much about what the platform is. Will the platform talk to it or not? So that's what we do. Some people like it, some don't. Some people appreciate the disruption, some don't. But I think the whole idea is, again, back to what I started off with. Things don't have to be that difficult. We all should have devices, plugs that can talk to any host. That's the whole idea of what Flex Optics does. This box does a bit more than just programming and reprogramming your transceivers. It's the Swiss knife for network engineers. It does more than just programming it for whatever host platform or whatever vendor that you have. We also have built-in laser here. As you can see, the laser is turned on. The built-in laser will allow you to do any optical power measurement. If you want to tune your wavelength, you're at a remote POP sitting somewhere, and you carry a wrong wavelength optics, don't worry. If you have the box with you, you can change the wavelength of the optics. You can tune it to any wavelength you want. And based on some requests from some friends of ours, they also wanted the box to do a bit of distance analyzing, so we've built in that feature also into this tiny box. So that's what we do. And we actually do it currently from 1 gig all the way up to 1.6 terabits. We're working on 3.2 and 2.4 terabits as we speak. I'll leave you with this. Thank you so much.
Kia ora, Tashi. I know there's a few people in this room, or the RIANS people, who'll be very interested in what you've just presented. And I just want to acknowledge Flex Optics as a new APAN industry member and fellow sponsor. So thank you very much for your ongoing support. Now, I'm really excited to introduce the next speaker. Klaus is someone I've known probably since about 4 years, since I got into role. Many of you will know Klaus from Géant as Mr. Edgerome. He, one of his legacies, you're a living legend, one of your legacies is Edgerome that we use all day, every day. And in his current role, Klaus is the Chief Services Officer at Géant, and he's come all the way down here to talk to us about what's going on in his world. So welcome, Klaus, and thank you very, very much.
Thank you, Amber. I'm a little bit disappointed that you chickened out on mentioning my surname, but it's so easy if you're Dutch. Good morning, everybody. First of all, thanks to RIANS for inviting me here. It's really a pleasure. My first time in New Zealand. I watched the Fellowship of the Ring in the plane over here. I thought otherwise they don't allow me in. And while we're at it, I have a few more confessions to make. One is Amber asked me to talk specifically about the EuroHPC Federation platform. I will talk about that, but not that much, because I thought the presentation should be of interest to the whole audience. Second, the title of the presentation is Authentication and Authorization. In fact, my message is much more in line with what the previous speakers have talked about, namely trust, community, collaboration. And I hope you will see that the work we're doing in authentication and authorization is really the embodiment of that spirit. We do things together because we do it better together than alone. Let's see if I can make the next slide appear. No, nothing. Green button. Is that what's supposed to work? Oh, Right, so Amber introduced me already, but very briefly about GÉANT. I think most of you will know GÉANT, but we connect the European National Research and Education Networks to each other, and as you can see on the second picture here, to the rest of the world. None of that is my work. I am in that right picture, the top two layers. I'm responsible for all the technology but the network. That means security, cloud, and trust and identity, and new service development. So, talking about trust and identity, and I start with the basic problem of trust on the internet. And that basic problem is that we have to bring two inherently separate things together. On the one hand, you have what is considered kind of the fundamental challenge on the internet, and that is to make things scale to internet scale. It's very easy to come up with an ID and make it work for a couple of tens of devices, a couple of hundreds. But when you talk about billions of devices, things get hard. And that was formulated long time ago by Mike Odell from UUNet, and I think it still very much holds. The problem with trust, as another technology philosopher said, trust does not scale. Inherently, trust does not scale. Trust is always between humans. And there is a lot of research on trust relations, and they all come up with something like you can maintain between 150 and 200 trust relations. So here we are. Problem of the internet, scalability. Problem with identity, with trust, it doesn't scale. But we did manage to make it scale. We did manage to build a service that reaches hundreds of countries, many thousands of service providers, many thousands of hotspots, if you call it, and that's the eduroam service. So how did we make this work? Well, one thing that I think is very important to realize is, if you look at that map, there is no such thing as eduroam central. There is no central place that manages the eduroam service, that makes sure that everybody can participate, that vets the participants, etc. What we have done is we built a trust fabric, and we built I think you could call it a hierarchical trust fabric. We have peers that trust each other and that in turn trust others. So very briefly, the National Research and Education Network has a trust relation with all the universities in the country, and they in turn have a trust relation with their students, and those National Research and Education Networks then collaborate together and have that trust relation with each other. And based on that human trust, we can make technical trust work. So that's one important characteristic. The other, and I will not read out this long sentence, the other thing is we started very simple. We just made it work. And over the years, eduroam has become a lot more complex. We moved from a simple radius-based system to lookups and dynamic trust establishment and all of that kind of stuff, but it doesn't really matter. That's not what eduroam is about. That is about optimizing what we're doing, making sure that local problems don't have a global impact, but it doesn't change the fundamental nature, and that is that we built a simple system and moved along and improved on it. And I think that is very much, again, the internet way of doing things. It's very hard to argue that, say, LDAP version 3 is a lot simpler than X500, which was the ITU standard for doing directory lookups. The difference is LDAP version 3 grew from LDAP version 1, version 2, etc., and it is fit for purpose. It's a very complex system, but it's fit for purpose. X500, even more complex system, but not fit for purpose. And that, I think, is the second lesson to learn here. Just start small and adapt to your needs and make sure that it keeps working. So with that in mind, we also try to do a very similar thing for applications. How can we make a federated access to internet services work globally? And this again starts with that principle that we start at the grassroots. We started now 25 years ago, roughly, with building national identity federations. National research and education networks would build a federation in their country that allowed students from a university to access Elsevier journals or services offered by other universities. And that kind of organically grew, and then at some point we said, wouldn't it make sense to do this also cross-nationally? Why would you restrict yourself to just in your country? Or, very pragmatic, why do you want to have a connection to Elsevier in 80 different countries? Why not one? And that led us to build a very thin glue layer, if you want, on top of those national identity federations called EduGain. And if you look at the technical part of it, it's really very, very, very simple. It is a host where all the identity federations in the world just publish the entities in their federation. So it's just a long list of identity providers and service providers, essentially. And again, same principle. It started like that. Now it is a much more complex beast that allows you to do very specific lookups instead of fetching every night the whole feed. And that's also because it has become successful, and it's a lot. It can take more than a night to download all of that data. So we had to come up with a better way of doing things, maybe comparable for you lower layer people to moving from a host file to DNS. That's kind of the type of things that we're doing in this space. So EduGain, not the reach that EduRoam has, not the numbers that EduRoam has yet, but that's not surprising. This is a lot harder problem to solve. EduRoam is simple. If you have a successful login, you get access to the Wi-Fi network, and that's it. And I joke often that with EduRoam, we compete with McDonald's, where you can get free Wi-Fi. There's a bit more to that. There is a trust infrastructure behind it that makes you be able to trust the network that you connect to much more than when you are at McDonald's. But it is a simple service, and it's very much in trust and identity terms, authentication equals authorization. When you look at EduGain, completely different story. EduGain, you are talking about access varying from a personal wiki of someone to a multi-million euro, dollar scientific experiment. And you cannot just say, if you successfully authenticate, it's okay for me. No, you have to implement very complex authorization rules to it. And that is why it takes a bit longer, but we get there. However, and this is where things get interesting, I think. We're now getting into the area where I spend most of my time on, and that is what happened a bit over 10 years ago. A bunch of research organizations came to us, the NREN community, and essentially said, you guys suck. You with your nice federated identity, federated login, all good and well, it doesn't work for us. And why did it not work for them? Well, I did talk a little bit about this the way we constructed our trust infrastructure, that essentially goes something like student to university to NREN, and then in Europe to GÉANT. But that's not how science works. This works if your users and your services are all in the same place. Then you can use your campus systems to regulate access, and everybody happy. But those bloody scientists, all of a sudden, they make science global. They collaborate with each other. They sometimes, I would actually say most of the times, affiliate themselves more with the scientific community that they're part of than with the institution they belong to. And that really complicates things a lot for our systems, because all of a sudden we have to think about what does it mean when you have a scientific collaboration with researchers from all over the world. One researcher there, 5 there, and then there are more of those collaborations, and more. And all of that means that it becomes impossible for university admins to keep track of. When you talk about serving the majority of the university population, you can get IT admins to do something special. When you want to go to a university admin and say, hey, I have here these 2 researchers in that faculty that need some special attribute because they are part of the Large Hadron Collider experiment. And oh, by the way, in that other faculty, I have one that is part of another collaboration. Can you also please configure our identity provider to release special attributes about that? It's just not going to work. Without wanting to be derogative, they are already very happy that they have an identity management system that serves tens of thousands of users and it doesn't break down. That's their mission, not to serve those few odd scientists out there in somewhere at their institution. So we had to come up with a solution. We had to come up with a way to say, this user, even though he's a scientist at the Technical University of Auckland, he's a principal investigator in the Square Kilometre Array experiment. And for that, we started a series of projects. We just finished the 3rd version of the ARC project. ARC stands for Authentication and Authorization for Research and Collaborations, if I'm not mistaken. And this is where NREN people and science people got together and designed a system that would work for them, that would leverage all the work that had been done on EduGain, but that would also allow you to model the type of relations that I was talking about, that would allow you to say, this person is the janitor of the university, but the principal investigator in this experiment. And the thing that makes that possible is what is called the ARC blueprint architecture, and that's a way of expressing those relations and allowing you to add information about the user. So you get a user in from a university or from another source, and you're able to, what is called in identity terms, decorate their identity with additional information about them. And this cake was created at the end of ARC 1, the first version of the project. We are now at the ARC Blueprint Architecture 2025, and if you just forget about the details, you will see that the same colors appear. Not a lot has changed. We've been using ARC blueprint compatible implementations for a number of years. There are some tweaks, but very roughly speaking, this architecture still remains unchanged. And without going into too much detail, really this is about is that in the center you have that yellow blob, and what that yellow part does is it takes identities from mostly Edugain, but also possibly other sources like electronic government-issued identities, or things like ORCIDs, or even social identity providers, if you're inclined to do so. It takes that and adds to that identity information about the user in the context of a specific collaboration. So if you are the administrator of the Large Hadron Collider experiment, you are able to say that person from that institution has this role in my experiment. And with that, you then can access the services, and the services rely on the information they get from the identity providers, plus what they get from this collaboration admin. And that worked. And we just finished the third version of the project, and there was again cake. That seems to be sort of like the thing that keeps us all going, the cake at the end of the road. But by doing that, we learned that we don't only serve those science communities, mostly the high energy physics community that were most vocal about their needs. But once we had this in place, we discovered that a lot of the questions that we get asked for support start to look awfully like nails where we are holding a hammer. And there is a risk there. There is of course a risk that once you have a tool that you tend to apply it to everything and kind of are blinded by other possibilities. But it has served us really well in the last couple of years. We have learned that precisely this architecture works very well for student mobility, for example. There is not such a big difference between researchers from multiple universities collaborating on a specific project to students from multiple universities, and you somehow need to administer that they're allowed to do an Erasmus, that's the student exchange scholarship for the non-Europeans, to do a half a year or a semester or whatever at another university. The pattern is very similar. And when we started talking about the European Open Science Cloud, and I will talk a little bit more about that, or the Euro-HPC, the high performance computing services, again, the same principles worked very well. We have an authenticated user with some information about that user, and we are able to add information to that. And because of the architecture, getting a little bit technical, but at the center in that yellow blob I was talking about, there is a so-called proxy, a service that sits between the identity provider and the service. And because you're in the path, you can do other smart things, like we have spent the past 25 years building a so-called SAML-based federation, Security Assertion Markup Language, and SAML is dead. It's not being actively developed anymore. The whole world is moving to OpenID Connect, but not. We have, as you saw in an earlier slide, we have tens of thousands of entities in Edugain that will not from day one be able to all of a sudden talk different protocols. Well, guess what? Because we are in the middle, we can do that translation for them. So we talk OpenID Connect, OAuth, short-lived certificates, whatever it is you want to use, we can just implement that. So it eases the transition path to new technology, another big problem on the internet. As the IPv6 people in the room will be well aware of, it's really hard to change from something that is so pervasive to something else. So what we built is a system, we call it the Core AI platform, that does all these basic operations that are the same across all these use cases that I was just talking about. And on top of that, we built 2 services. My Academic ID, the service that supports student mobility, and my Access ID that was originally built to support the HPC community, but that we have expanded to also support the European Open Science Cloud. And with that, with this platform, we can now support the whole research and education column and address so far all the use cases that have come up. And that is, I had in a previous slide, I talked about sort of an existential threat to NRENs, and I really think it was an existential threat. We really were at a risk of being kind of disintermediated, being taken out of the flow, and then why are we here? We are not here because we can deliver cheaper connectivity. In some places, yes. In other places, not. We have to bring this element that Amber was also talking about, the community bit. We are together. We trust each other. We do things together. So, very short, what is this My Access ID service? And I will go a little bit fast through this. Essentially, it is using what you have been using all day at your university, and you can use that identity to also access other services. You get outside your university, you get your nice single sign-on experience, so authenticate once or once a day maybe, and seamless access to all services. In theory, across all domains. It's usually a policy decision whether that's possible or not, but technically it's not a problem. We can, with one identity, we can do across education use cases, across HPC use cases, and about scientific use cases. And I talked about this service being in the middle, and that allows us to do smart things that I talked about already. So where is it used today? Well, apart from education, My Access ID is used essentially everywhere else but education. We are discussing, should it be possible to just use My Access ID everywhere, but that's a strategic discussion for a later moment. But for now, My Access ID serves the whole science column, if you want. And a few words on those 2 use cases. The European Open Science Cloud, the overarching idea, if you want, is a researcher from a particular domain is able to access resources from everywhere, from other domains as well, with the thinking that new science is formed by stepping across thematic boundaries. And the European Open Science Cloud tries to do that. Their own slogan is the web of fair data, but that maybe raises more questions than it provides answers. So I'd like to stick with a researcher can have access seamless to resources that are of interest to him wherever they sit. And that is implemented by a system of nodes. The term that we coined at the time was a system of systems. And then you need to be able to interface these systems. And in order to do that, you need a common identity across all those systems so that a system in one of these nodes can trust a user associated with another node. And we did that, we built that on top again of the My Access ID platform. I will not go into more detail for the risk of losing 3/4 of the room, but I did provide the URL of the Synodo document on my slide, I very much encourage, if you're interested in this field, to have a look at that document. I think it turned out as a very useful and good document that explains very well why we have made certain architectural choices and how we implemented it. So warm recommendation to have a look at that document. But to give Amber what she wants, also a few words about EuroHPC. Just kidding. I think this is actually something that should be of interest to a lot of you. And it's about how we can essentially what the Americans would call punch above our weight. What happens in EuroHPC, the overarching thought kind of is, yes, there is this sort of weapons race, who has the most powerful supercomputer, and we in Europe participate in that. We build bigger, faster, stronger supercomputers all the time, but in the end, this is not sustainable. In the end, we should leverage the fact that we are collaborating, that we have trust between us. So in fact, what we should be looking for is, if you want, a virtual supercomputer. And we do that by having those individual supercomputers being networked very well. This is what is called the so-called hyperconnectivity network that GÉANT, together with the European Research and Education Networks, provides. And a layer that allows for that collaboration. And that's called the EuroHPC Federation Platform. And I think I kind of repeat myself by quoting what the thinking behind the EuroHPC Federation Platform is. It is that seamless experience across all those systems. As a user of a HPC center, you have an account with that center or with an institution affiliated with that center, and with that identity, you can also run your jobs somewhere else without going through lengthy review processes and all these wonderful things that are happening in the HPC world. One of there are 6 core services defined in the EuroHPC Federation Platform, and one of them is that single sign-on service that is based on my access ID. I see that my numbering is not really up to speed. I have 2 number 1s, but it consists of a number of components. We deliver that federation component that ties all those HPC centers together, and we implement some additional services inside the centers, and then we work with a number, strictly speaking, not part of the Federation Platform, but all those organizations that need to connect also need their own AAI. So we do help some of them also with their AAI. And I think this model, and this is why I think it is relevant for this audience, I think this is a replicable model. The fact that this is stimulated by the EC doesn't mean it cannot be done elsewhere. I really think we are able to use the same model and have this much more global collaboration on these kind of services. I think I'll just skip to leave a bit of time also for questions. So, as I said, this is not, the real lesson is not in that we can make a system that works. We can, we know that, we do collaborate, we have a lot of smart people together that together build solutions that work. So the system itself is not interesting. What is interesting is what I just described. What is interesting is that we do get together in working groups, that we do get together in conferences like this, and that we have an open exchange of ideas, and that we stand with a bunch of techies in front of a whiteboard and make something. I don't, for those of you that have never worked in a pure commercial environment, I can tell you this is unique. I've worked for 9 years at Cisco. No way we would get in the room with Juniper to design a nice system. We would lose our competitive advantage in that. But we don't have a competitive advantage to each other. It's to our benefit if JISC develops a wonderful solution that we can adopt, or that Rian's comes up with a really good idea that we can use. So we all benefit from collaboration. And that brings me to my last message. Well, actually, this is not it, but this was supposed to be a 20 millisecond subliminal message that would inspire you for the rest of the week. No, my final message is this, and that is that looking back at 25 years of EduRoam, almost 25 years of EduGain, it is all about us doing things together. EduRoam, yes, the first spark came from me, but I cannot take credit for the success of EduRoam. That's hundreds, if not thousands of people that believed in the idea and brought it forward. In New Zealand, in Australia, in Asia, we do this all together. And as the saying goes, if you want to go fast, go alone. But if you want to go far, go together. So let's go together. Thank you. Questions? I was supposed to leave 5 minutes for questions, so if you now don't ask questions, that's disappointing.
I have one. Is this working? I've got one question from a non-technical person, so apologies in advance. How does My Access ID integrate or work with the local federated identity? So we've got Tuakeri, which links into EduGain. Does that link into My Access ID the same way, or does it replace what we do locally?
No, it builds on what you're doing locally. So 90% of the identities that we consume in My Access ID come straight from EduGain. So your federation identities can be used, technically, I should say, right away, today, for access to your HPC. In fact, we have discussed with some researchers in Japan, for example, and we have trialed it, and it works seamless. That's not a problem. It's policies that get in the way. And however much I would like that not to be the case, that's often the case. Those that give the money are the ones that sort of try to restrict, and it's kind of counter to what I believe research should be about, but it is a world we live in.
Thank you, that was fabulous. And I must say I'm in awe of being in your presence. You know, when you go around the world and walking down the streets of Porto last year, and all of a sudden it flashes up, you're connected to EduRoam. Yeah. How fabulous. So my question is this, future. What's the future look like? What's next? You know, what are you working on now? You know, where are the possibilities?
Yeah, so first of all, I still have that same amazement whenever I go somewhere. And like I walked by Auckland University of Technology and, whoa, I'm connected. So yes. I think we're working on many different axes. If I were to pick two, I would say security. We are kind of trying to close the gaps in the whole column, from onboarding a user for the first time to using EduRoam all the time to server communication. I think we are pretty much there for the latter two. The first one remains a big problem. How do you do that initial rollout? And we kind of suggest that universities do that on registration, take them by the hand, configure the devices, but then after that, you have no control anymore. So we have built an application called Get Eduroam that uses your EduGain identity to issue a certificate or other types of credentials that you would like. And that really closes that gap. Still, if you go to the Apple App Store or the Google Store, you will and you search for Eduroam, you will find a bunch of rogue applications, and we can do very little about it. We know that from research that if you put a pop-up in front of a user that says, do you want to trust this certificate? They just click yes. Because the question is, do you want access? Yes or no. The question is not, do you trust this certificate? So we want to avoid that pop-up at all cost. So we develop tools that avoids that. The other part, very non-technical in a way, is about broadening the footprint. And for that, we collaborate, for instance, with the Open Roaming initiatives. That is kind of Eduroam for the rest of us. An initiative from the Wireless Broadband Alliance, and essentially they took the Eduroam architecture and said, what they do, we can do too. So we work with them, and the whole thinking behind that is it will increase the chances of what you just described, being wherever and getting access, and getting trusted access. So I think those, I would say, are the two most important developments we're working on.
Thank you for the presentation. I'm a question on the Eduroam service provider. Well, we want to have more access for Eduroam for our partners all over the world, like the airport in Hong Kong, the library, the museum, the convention center. But we found that it is very difficult to convince those government agencies. They are very conservative. Yeah. And commercial partners that didn't want to share the resources for the community. Do you have any suggestion for us to convince those people how we can gather those SP, the service provider, for us?
Short answer, no. But a slightly longer answer, this is really a hard problem. And I think, I hope, I should probably say, I hope that it's not so different from the problem we had in the early days of Eduroam. At some point you need a certain critical mass where you move from how do you justify doing Eduroam to how do you justify not doing Eduroam. And that took 10 years. And now, if you're a university and you don't do Eduroam, you're wrong. So we made that transition, but that's much harder for service providers. What I have seen work is, for instance, for airports, point to other airports that do it and say, look, all over Sweden and Norway, every airport has Eduroam. Why don't you have? And some of them are susceptible to that suggestion. In a lot of cases, it's purely commercial. In the Netherlands, where I'm from, we have never managed to convince Schiphol Airport, the main airport in the country, to do this. That's because they make a shitload of money on providing Wi-Fi to a bunch of these commercial Wi-Fi providers. And they just don't want to undermine that business. I think it's wrong, but that's how it is. And the third thing I would say is, going back to the previous question, open roaming hopefully solves part of that problem. What you need to understand is Eduroam, the Eduroam SSID was at some point the number 8 most used SSID in the world. I think it's a bit lower now. But SSIDs are scarce. It's a big deal to configure a certain SSID on an access point. With open roaming, you don't need that anymore. So you can just call it I don't know, Hong Kong airport Wi-Fi, and under the hood you can use your EduRoam credentials. And I think that might also cause a shift and increase the likelihood of you being able to use the Wi-Fi network at those kind of locations. But there's no simple answer, so that's why I started with no.
Last question.
Thank you, class, for this wonderful presentations. I didn't have questions, but I just want to share our experiences regarding the EduRoam connections at T1 International Airports. So we applied the two approaches. One is we talk with our research and education communities and suggest them to create some kind of pressures from their sides as well, because they usually do a mobility through the airports, and the connections will be very important for them. And another is we talk with the international airports authorities, and we convince them that that will be the support for the research and education communities in Nepal and other as well. So that will also help them for the visibility as well. So finally, they convinced with that one, and the good thing is we are not paying for the internet bandwidth for the airport. We are using their bandwidth, so they just agree, finally agree. But yeah, it's not the easy way to go through, but it took some time, but now it's working. Thank you. Thank you, class.
Thank you, and this is a good moment to also then say that you are doing amazing work in Nepal. I'm super impressed with it, so congratulations on that.
Thank you, Klaus.
You're welcome.
Klaus is here for the next few days, so I think you're going to be hit up at drinks with lots of questions. A wee spoiler, not a spoiler alert, the Euro HPC model, Rianne's is implementing that regionally at the moment, so we'll be talking about that in ASITA's HPC session on Friday morning, if anyone's around. So thank you for proving to my chair that this was the right thing to do. We're now at the point of the session where we're going to be signing some MOUs, which is fantastic because this is a real tangible expression of the collaboration that exists across the region. So the first signing is the pairing agreement between Géant and Cernet. So Klaus Waringa and Zonghee Lee, can I ask you to come up to the stage? And there is just a table being brought now, so.
Yeah, so sorry. Okay, thank you. Yes, later. Okay, so thank you, Amber, and thank you, chairs. And firstly, I would like to extend my sincere appreciation to the APAN program committee for organizing this important signing ceremony for the interconnection between CERNET and GENT. And on behalf of CERNET, it's my great pleasure and honor to sign the agreement here. Actually, this important milestone reflects our shared commitment to the strengthening the collaboration among the research and education networks. Actually, the collaboration, our collaboration with the European Research and Education Community has a long and successful history, dating back to 1996 and 1997, when the direct connections was brought up between CERNET and the DFN, and between CERNET and GENET. And then in 2005, CERNET and GENT established 622 Mbps interconnection through the 10.2 project. And then thanks to the Orient and Orient Plus project joint funded by China and Europe, we finally upgrade this link to 10G in 2015. Now, today, we were proud to take another significant step forward with 100G interconnection agreement between CERNET and GENT. And we look forward to deepening our partnership and to creating more greater opportunity for the cooperation between CERNET and GENT. And also, and last, please allow me to give the warmest gratitude to all the colleagues and partners who have contributed to this achievement. Your dedication and trust, and also the spirit of cooperation demonstrate the power of international collaboration. Thank you so much.
Yes, and you've heard me long enough, and in reality I'm just a pretty face on the stage. The real work has been done by the respective teams in our organization, so I want to take this opportunity to thank them for all the hard work and leave it at that. Thank you.
The next MOU we're signing is between Tainstar CC and Transpac. So it's Edward Moynihan and Patch Lee. Edward, I think you've prepared some words, as I understand it. Oh, no.
Ladies and gentlemen, now we'll proceed with the signing of a Memorandum of Understanding between Tainstar Cooperation Center and Transpac Indiana University. Earlier this year, the two organizations successfully strengthened Trans-Pacific and North American connectivity through strategic network peering, establishing a highly resilient pathway for global research and education. Building on this success, today's MOU marks a vital step in mutual partnership. This collaborative framework will not only enhance the stability and resilience of network infrastructure, but also drive key joint initiatives, including joint network research, above-the-network services, and open access environment to empower science, education, and health science research communities across the two regions. So may I now ask you to sign the Memorandum of Understanding?
All right. Good morning, everyone. So for the next MOU, can we have the representatives of Shinji? Professor Shinji Shimojo, the chairman of Shinji. Shinji is a general incorporated association established to facilitate coordination among the Japanese research and education networks to promote international collaboration. Next on, representing JUCC, located in Hong Kong. The JUCC coordinates and develops advanced IT services for higher education and research. It funds and operates HARNET, Hong Kong's advanced research and education network, which connects member campuses to the global internet and supports international peering through its R&E node. Please welcome Ms. Carol Chew, Director of JUCC. Representing Singaren, as Singapore's National Research and Education Network, Singaren is dedicated to serving the R&E community through high-speed fiber networks. Its open exchange connects Singapore to global R&E networks across Asia, Australia, Europe, and the United States to facilitate massive data set transfers across international boundaries. Please welcome Mr. John Lau, President of Singaren. All right, the objective of the collaboration. The landscape of scientific discovery is changing rapidly. Today, explosive growth in high-resolution imagery, video, and scientific sensors has led to unprecedented volumes of experimental data. Complex multidisciplinary challenges from healthcare and public policy to scientific discovery and economic competitiveness are no longer confined to a single country. Instead, important discoveries are being made by teams of experts spread all around the world, collaborating and sharing data across national boundaries. To support these vital multinational partnerships, our participating networks have decided to contribute specific resources from their individual investments. By working together, they will create a resilient, flexible, and consistent transoceanic network services delivery systems. The primary objective of this MOU is to take advantage of the rich topology to build multiple parts of Fuji XP between R&E networks and to establish a shared framework for production quality, transoceanic networking, and data exchange. By connecting through Fuji XP Global Exchange Point, these leading-edge networks aim to elevate R&E services globally and continually stimulate the development of advanced use cases and applications that benefit from high-speed international connectivity. So I'd like to invite the parties to sign the Memorandum of Understanding. Thank you, and congratulations to Shinji, JUCC, and Singaren. Next on is an exciting exchange. Can we have the representatives of ARNET, Arena Pack, Internet 2, IPA, JUCC, CREONET, NIA, NII, Pacific Wave, Rians, Singaren, Transpec, and that's like the whole hall, and UH for the Asia-Pacific Oceanic Network APANET collaboration. And I believe, Edward, you have got something to say? All right, go ahead.
Don't worry, we've already signed the document. Everybody here? All right. So today we're pleased to mark the signing of the new APONET MOU. APONET stands for the Asia Pacific Oceania Network that brings together 13 R&E organizations. APONET is a collaborative high-speed network system built from the circuits, exchange points, and other resources contributed by its members. By coordinating these individual investments, the partners create a more resilient and flexible transoceanic infrastructure than any one organization could provide on its own. Our renewed MOU reflects the strength of the partnership that we've already built and extends our commitment for an additional 5 years, providing continuity for the joint work, technical coordination, and shared investments that will carry APONET into the future.
Thank you, everyone. I'm delighted to introduce our last keynote speaker of this opening session, Matthew Lucky, from the consulting research scientist from CAIDA. So welcome. Are you okay?
Yep. Okay. Cool, thank you. So this is a much more technical talk, perhaps, than is appropriate for a keynote, but it's a talk that I think has a lot of relevance for the NREN community. So this is a talk about a project called Root Beer. It's a collaboration between Internet2 and CAIDA, and I'm from CAIDA. And the goal of Root Beer is to equip worldwide R&E operators with tools to help them answer questions that are relevant for R&E networking. It helps. One of the goals is to help you validate your routing intent. So the idea with R&E networks generally is that it's great if scientific traffic stays on R&E networks. It's the reason why they exist. So we want to validate that this is occurring in practice. We also, because typically R&E routes are the best paths for most networks, route leaks have high impact because those prefixes get the best paths for most networks, and then they'll attract traffic that perhaps they're not intending to have. Another goal is to try and help visualize the global R&E routing topology to see exactly what paths are available and which paths are selected, and to improve BGP security through technologies, RPKI, ASPIS, and so on. So the RootBeer project itself has a web page, rootbeer.internet2.edu, and on that page is a number of tools. This is all public. And I'm going to take a step through two of the tools today, the R&E topology report and the local preference probe, the first two on that slide there on the website. And while the examples that I'm going to give today in the talk have a North American focus, that's primarily because they're nice, concise, clear examples. But again, the report and all the data that we have covers the global R&E ecosystem, as you can see in the slide there. Most of those networks listed are in the APAN region. Okay, so on the R&E topology report. So what the R&E topology report equips the network operator to do is hopefully understand their full topology and how they fit within the R&E ecosystem. We also want to be able to easily show if there are examples of routes that are being leaked into R&E that perhaps should not be there. We also want to be able to show in that report the network's routing policy. So for example, are the members downstream from us, are they doing the right thing? Are they preferring R&E routes over commodity routes? Or are they leaving it to chance by choosing the BGP route with the shortest AS path? We want to understand if the member networks are holding full internet commodity routing tables in addition to holding R&E routes. There are subtle reachability issues that can occur if they don't hold a full commodity internet routing table. And also, in terms of how they're announcing their address space, their prefixes into the world, is it the case that the members are announcing more specific routes than those that are in R&E that would then force other networks to take the commodity paths into their networks? We also have in the report a visualized way to see if the prefixes in R&E are correctly covered by ROAs and ASPAs. Are the R&E route announcements consistent with IRR route objects? If that's not the case, then some R&E networks will filter out those prefixes, and so the announcements that you're making might not be having the effect that you think they do. And also in the report, you can see the location and the topology of some specific specific scientific infrastructure, NRP nodes, EGO, Federation nodes, so on. And then also network measurement infrastructure that might be useful operationally to debug problems. So for example, the locations of ARC nodes, of RIPE Atlas nodes, of Perf Sonar nodes, and if that might help. Okay, so I'm now going to start to talk a little bit about the visualizations that the report relies on. And so this is sort of going into the weeds a bit, but it's a visual way of explaining what's going on in the routing system. In terms of the building blocks to this root-based system, what we have to start with are 49 Internet 2 routers that are reporting their pre-policy routes. So what this means is we're seeing all the routes that come in from all of the peering sessions to those routers, and we're not just seeing best paths. So we see both the routes that those routers will accept and also the ones that they'll reject, and also obviously the presence of alternate paths should one of the links go down. So there might be about 25,000 odd routes in the R&E ecosystem. In total, the pre-policy routes come out at about 137,000 because there's obviously duplication from different across pairs and across routers. And on the right-hand side are routers. In this case, 3 Internet 2 routers, one located in Ashburn, another one in Washington, and then another in Washington, DC, and another one in New York. And the example that I'm working through is a R&E network in Washington, DC, which is why you're seeing East Coast routers there. We see Next in the path, a node representing Internet 2. So everything else from this point on is at the AS level, because obviously we don't know the router level paths beyond this. You'll see that there is a ribbon between Internet 2 and then the specific routers that are involved. In this case, you'll note, so one more ribbon in. Now we bring in Karen, this network, this Washington DC area network, RNE network, and we can see in this topology that Karen isn't pairing directly with the Washington router and is pairing with the Ashburn and the New York router. In terms of those ribbons, the ribbons sort of show the flow of routes from origin to, in this case, the Internet 2 view. And so the ribbons are a group of routes that share the same properties. And then finally, we have on the left-hand side Karen's members, 4 of them in the Washington DC area. And then also part of this diagram is another AS, Max Gigapop. And what we can see in this, so in this case, the reason why those nodes are coloured orange is because we're colouring nodes based, in this case, on the first hop from Internet 2, the Internet 2 connecting AS. So because Karen's routes also are carried by Max Gigapop to Internet 2, those are coloured orange. And you'll note that down in the bottom now, Max Gigapop is providing Karen routes into Washington DC. So that's showing a little bit more resilience there and also where those routes come from. The green markers that we have around those nodes, what they mean are that those ASs host some specific science measurement, science infrastructure like the NRP nodes, the EGI nodes and so on, or Personar or what have you. And then why we think this is a particularly useful way to look at routing is for examples like this. So this is a Karen example, and what happened was we produced the reports and sort of made them publicly available, and some operators went along and could see immediately when they looked at the network that in this case those red routes, they looked odd. They clearly looked out of place. First off, they're coloured red because these are rejected by Internet 2, but also because they're also have very long AS paths. So something looks fishy here. And immediately, because those jump out, you can go look to find out why that is. And in this case, Andrew Gallo, who's an operator at Karen, and we're big fans of Andrew Gallo, went and fixed the routing policy because it was so obvious that something was going on wrong here. And in terms of why we think this visualization is useful, this information's also been in tabular reports for a very, very long time. But those tabular reports, things don't seem to jump out at you as much as a visualization can. So that's sort of the basics, these route ribbons as a building block to the root beer topology report. So far I've told you a little bit about how you can see the full RNE topology, well, the topology that Internet 2 at least sees, and see some route leaks and see things that might not be intended. Now I'm going to talk to you a little bit about how we infer routing policy. Do the member networks downstream from us prefer RNE routes or not? And in the website, when you go and look at these reports for these ASs, what you will do is you can change, instead of colouring the Sankey diagram based on the first hop past Internet 2, instead you can tell it to colour it based on some other property that we're interested in. In this case, routing policy, this LPP result thing. And I'll talk you through that shortly. Right, so we're starting with a Sankey diagram that looks like this, that's currently coloured based on the first hop past Internet 2, and now we're going to colour it based on this thing called the local preference probe result. I will talk you through the details of how we come up with these inferences shortly, but just to briefly start with, these grey nodes, what that means is that those ASs, as best as we can tell, prefer RNE routes. They're all fine, they're colour grey, so to sort of de-emphasise them, if you will. The one at the top there, that's coloured to dark blue, you'll notice it's a scale there that goes from 0 to 100%. That means, in this case, that systems in those ASs are not following RNE paths. Right, so how do we infer this? So this is a challenging problem to answer because BGP is not telling us anything about the routing decisions made downstream from us. We can supply routes to our members, but we don't know what they do with them. BGP is not going to tell us that. What we'd ideally have maybe is a view from those networks, a BGP view, but very few networks provide BGP views publicly, so we can't easily answer that. So this is a challenging problem, and I'll tell you a little bit about how we're inferring this. Using a second tool called the local pref probe. So the goal of the local pref probe is to try and infer local pref assignments in BGP. This is the second tool, and you can it's a standalone tool, but we also use it ourselves every day to probe all of the RNE address space available that we see, and then summarize the results and make them public. But into that sort of form, you can put in a domain name of some system that you know is an RNE and then probe it to see what it does, maybe a data transfer node, maybe some science infrastructure, or a prefix if you just want to know a little bit about a specific prefix. Okay, so now I'm going to get really into the weeds. So I want to tell you a little bit about how we go about inferring local pref. So what we have is a probing system located in Internet 2, and that probing system we send packets from to responsive systems around the world in RNE networks. We ping them. And that system has two network interfaces, one connected into RNE and another one connected into commodity. And then based on the interface that we receive responses from, we can make an informed guess about how those packets have been routed to us. Did they arrive over a commodity interface? They followed a commodity route. If it arrived on the RNE interface, it followed an RNE route. So we need a responsive system. That system has a number of addresses configured on it, IPv4 and IPv6 addresses, and we have some BGP announcements related to each of those addresses that are announced in a specific way so that we can make informed judgments about what those networks are doing. In this case, that blue address is located in a prefix, in a /24 prefix, that we announce into RNE, prepended 4 times. And we announce it into commodity without any prepending, so that the RNE path probably has the longest AS path. And so if the network is choosing routes based on AS path length, then it will be not a favoured route, probably. We also have another route that is, sorry, I've got it around the wrong way. This one is the one that's prepended 4 times into RNE and not into commodity, but it's the same thing, where we prepend one announcement into RNE for one of the prefixes and prepend the other announcement into commodity for the other prefix. And then finally, we have another address and another set of prefixes that allows us to guess whether or not the network has a full commodity routing table. Are they holding commodity routes in the network? So what we do here is we have a /24 that's announced into commodity and a less specific /23 for the same prefix, for the same address. And if the responses arrive in over commodity, then we can infer that they have a commodity routing table, because otherwise they would have followed their longest matching prefix, which was via RNE. So this is to the CADA website, and this is what we typically expect to see. We probe with the blue address, it comes back over the RNE interface, it's not prepended, it's what we'd expect. And it continues to come back into us when we probe with the green address over RNE, even though it's a longer AS path route. And so from this, we infer that they're assigning a higher local preference to RNE routes. And then finally, the last probe comes in over commodity because it's the most specific route and they're holding a full commodity table. This also works for V6. The system is configured with IPv6 addresses. We can see for some networks different routing policies for the same systems outside of in V6 compared to in V4. If they don't have a commodity table, then all three responses come in over RNE. If one response comes in over commodity and the other one comes in over RNE, then they're assigning the same local preference, so they're not assigning higher local preference to the RNE routes. They're not preferring RNE as policy. And then finally, some networks prefer commodity, perhaps they're not holding RNE table and all the responses go in via commodity. So that's how we got to the dark blue ribbon. A little bit about the magic behind it. Okay. So now I'm just going to tell you a little bit more about looking into the existence of more specific routes than those in RNE that force traffic to come in over commodity instead of take an RNE path. So back in our topology report, we changed the colouring of the ribbons from local pref probe results in this case to the more specifics. And we'll end up with a graph that looks, in this case, like this. Again, the top two ASs, there are no more specific routes that we're seeing in commodity. So where we get these from are we look in route views data for tier 1 ASs in the path, and if we see more specifics of RNE prefixes held by those tier 1s, then we assume that then we infer that they're announcing more specifics into commodity. So those top two aren't doing that. They're coloured grey, but the bottom two are. So the darker the blue, the more of the address space that they're announcing is covered by a more specific. So the darker the blue, perhaps the worst things, well, for RNE networks, it's not ideal. And so we might want to know, well, what is going on there? What is an explanation for what's going on here? We can go and drill down onto this. So the RNE topology report will allow you to go in and say, show me the commodity routes. In this case, those are coloured pink because they're more specific routes, but they could also be coloured purple if they're just regular, if they match the RNE routes prefix lengths. For the purposes of this presentation, what I've gone and done is in the report, this is a public website, you can do the same, you can go and say, don't show these other nodes that aren't adding more information or aren't adding to the point of what's going on here. And so I've gone and removed a bunch of other tier 1 ASs from the list, just to leave the essence of what's going on here. Right. So in terms of that top one, what's going on there is that network has a Cloudflare provided always-on DDoS scrubbing service, and there are other providers of such a service, but we can see that there. So sort of how we can sort of drill down into this is we can go and click on the node in the RNE topology report and open up a menu and say, show me all the routes originating from this address, sorry, from this AS. And we'll get a pop-up that looks like this. It has 4 prefixes in it. The bottom one is a /16 and IPv4/16, and we'll see 2 /17s entirely covering that 16 that are announced only into commodity. So that's what's going on for that one. They're using Cloudflare to scrub all their traffic in And why this might be of particular interest into RNE is that there are also RNE provided solutions that use these DDoS scrubbing services that would allow the network to continue to receive traffic over RNE. So perhaps it's worth following up. And then that bottom one, there is another /16 involved, but they have only 2 relatively small prefixes involved. They might have a reason for announcing those more specifics, but again, if this is of particular interest, then you can go and follow up with what's going on. Okay. So that's sort of the essence of the RE topology report. There's more detail that you can do just by clicking on more of the features. So for example, when we listed those prefixes before, you can click on the prefix and see actually what's in there and more information about them. In this case, we can click on a prefix, and this is routed by the University of Tokyo. What we see here is that Internet 2 is receiving routes for that /16 from 3 different pairs at 3 locations. We can scroll down and we can see some information about the routes involved. So we see 3 routes for this prefix to start with, well, 3 unique routes. The top one is the shortest AS path. We can see there's no prepending involved. But the next one down, for whatever reason, I don't know any reasons, the middle one is prepended by multiple ASs in here, both the origin and a network in the middle. And then down the bottom is another route that's also available with no prepending. It's a longer AS path, but we can start to see what the paths are that are available into that prefix should there be an outage or of some sort, or what other decisions other networks might be making about what their best paths are. We can keep scrolling in the report. It will tell us about any nightly local pref probe results that it has for systems in the prefix. So what it's doing is we're looking in a hit list for responsive addresses and probing them. Hopefully they respond to us. This one's fine, it's all green. We can see that the network is holding a commodity table. We can see some routing policy up the top there. We see that they have an entry in RADB and the origin matches what's in IRR. We can see that the network hosts an Atlas node. It has 4 Perf nodes, and it also has some other science infrastructure in there, and that is all doing the sort of the right thing, and when we probe it, and that it's replying over RNE. There are some other canned reports in the topology report that you might find particularly interesting. You can go and click show me all the Anycast routes that are announced in the RNE ecosystem. And why that's of particular interest is that because most RNE networks prefer the other RNE routes, if an Anycast prefix leaks and is advertised into RNE, then most institutions around the world are going to use that route even if there's a closer instance available. And then also there's a report where you can say, show me AS paths with a tier 1 AS in them, something that's probably anomalous. Those are likely leaked. We can go and maybe tidy up our routing policies. I'll just finish with another visualization because again, we think that these Sankey diagrams are quite compelling. So what this one is for one Anycast prefix that's advertised into RNE, and it's represented by the blue bar on the right-hand side. What are the routes that we see from other, in this case, ARC nodes? What are the paths to that Anycast prefix? And then how inflated is the RTT because it's using an RNE route? In this case, those blue bars, those are RNE networks. I've removed all the ASs so you can focus on the fact that the blue ones are RNE, and then the orange nodes, those are commodity ASs in the path. the more red the colouring, the more inflated the RTT is. And we can see that because worldwide RNE is largely choosing that EDICAST prefix in RNE as its best path, it has a much more inflated RTT than if it was if that route wasn't in RNE and they were choosing a closer commodity route. So this is sort of where things can go a little bit hairy in RNE. So that's that visualization. It's another public report. Go and scroll down in the root beer page and take a look. And so I'll just finish now with a call to action. Go and take a look at the root beer website. Have a look at the reports. Browse things through your networks. You might learn something about what's happening in practice with your network. You can validate that the intent that you have is actually reflected in the routing topology. And we're also happy to sit down in person at APAN or via Zoom. Steve Wallace, who's leading the project, would love to sit down with individual operators and work through reports one-on-one and tell you more about what we can see and things you might consider doing to improve the overall RNE ecosystem. We'd be interested, because so far this view is based on what we're getting from Internet 2. We can take pre-policy routes from other networks that are interested in collaborating with this, so we can see more of the topology and more of the routing decisions that are made across the ecosystem, and also consider hosting an active measurement node that could allow us to uncover more fine-grained local preference assignments in RNE networks and provide feedback. There's an email address that will reach the project at the bottom there, rootbeer@internet2.edu. Thank you for your time. There's a microphone over there. Cool.
No, thank you for your time. I know many of us will hit you up afterwards, like a few REANS people I saw intent.
Yep.
So, Kira, Matthew, I love the project name. I think it's one of the best I've seen for a while. That's it from me. Thank you so much for your attention through what I know has been quite a long opening ceremony. So I really appreciate that. Now it's time to go and get some kai, which is food, some lunch. So enjoy your break. I enjoy chatting to each other and just swapping ideas as we do at APAN. So enjoy your afternoon. And I look forward to seeing you for drinks at Weta Workshop this evening. And just so you know, Weta Workshop are the people behind the Lord of the Rings, those amazing costumes. So I'm hoping it's going to be a really interesting evening. Kia ora.